Hi, welcome to part 5 of the Nixie Tube display project. Part 4 we left off actually doing the routing for the PCB, and so it'll be click here up in the card up in the top right corner if you haven't watched that. That's like how to go through and actually route and lay out a board. And by the way, there was actually one error in this board which only one person found this error, is that my packages here, these SO packages, I actually used the narrow version of these packages, and the chip, the TPIC 6B595 only comes in the wide-bodied package. So yeah, trap for young players, and well, I didn't spot that and goofed it up completely. It would have been okay if I went and got the board manufactured. It would have been fine because you can actually bend the legs under these chips. You can actually bend them back under, so turn it into a J-lead package where it comes back under, and then solder them down like that as like an old school J-leaded package or whatever. So yeah, it would, because there's not a huge amount of width difference in there. So we could have kludged it. It wouldn't have been a showstopper. It wouldn't have been great for production, of course. It would have sucked. You would have fixed it for production. But given that this is a one-off board, it would have been fine. But anyway, we went through and fixed it. Actually, David went through and fixed it. David too is over there. Say hi, David.
Hello.
He's in the same room. And so, but an interesting thing happened, right? So I just gave him the task of going through and changing the from a narrow package, which the pins were up here somewhere. I could do a side by side, but they were, like there was 3 or 4 millimeters in it or something like that. So change it all, but that changed all the routing and everything. But we haven't got like all our machines set up and all our libraries set up and everything yet. So I sent him the the project files and everything else, and he edited it on his version of Altium, and it actually swapped. You'll notice that I used SMD resistors before, but now it's got these through-hole resistors in here. And Dave didn't know that because he hadn't seen my video, so he didn't know that I used SMD, and he just assumed, as you would, that the PCB package is right, and it somehow swapped all of the SMD resistors to through-hole. And these ones on the bottom I've had to change back manually, by the way. So what it did is, we believe it changed it definitely added the package reference in here as axial 04, and it actually deleted or it added an extra axial 04 in here and changed them all, and it didn't warn him or anything. It just happened, so he just rerouted it based on that, and he sent the board back to me, and I was a bit confused for a few minutes, and like, did I use through-hole resistors before? But no, so we're not sure if that's a bug in Altium or what not. But anyway, so I've just left them. I've changed the ones on the bottom to through-hole, to SMD, but I've left the ones on the top just because to change those would require going in and rerouting a whole bunch of stuff. It'd be like, I just couldn't be bothered. This is just a one-off board. So anyway, what we're going to do today, sorry for the waffle at the start, is we're going to actually get this board manufactured. So we've finished our routing. What is the next step to getting it manufactured? So let's go through it. Now, first of all, you'd want to, I probably said this before, but you want to use the 3D view. And this is where 3D view is fantastic, not for the packages. In fact, you can get rid of the packages and just look at things like solder mask expansion, for example, in there. Do I have solder mask between all of my pins? And you can capture all, you can get this sort of stuff using DRC rules and stuff like that. But nothing beats a good visual look at what your board is physically going to look like when you get it manufactured. And that's the great thing about 3D viewing. So yes, whilst all these 3D models are all great and everything, you actually want to disable those. So if we go into PCB down here and PCB window and then 3D models down here, we can actually disable those 3D bodies showing up, and bingo, this is what our blank board is going to look like. This is what it's going to come back from the manufacturer as, and you can see that you've got solder masks between stuff. You can see whether you've got tented vias or not, which we do have some tented via, like this one here is untented. Oh, look at that. So that's a complete, where was it? There it is. That's a complete fail. So Yeah, it was that one, was it? It wasn't tented. There we go. Force the tenting on top. I may have covered this in the previous. There you go. And you can see actually the holes are. The holes are tented there, which means tenting just means the solder mask goes over the holes basically. And not always. If you've got really large holes, it obviously it's difficult to completely cover them. But if they're small enough, then you can do that. We don't care about under the chips because, as I said, this is going to go into a box which will have like just a simple rectangular cutout on here. So anything that looks through here like this will be visible. So if you've got like components in here, they will be visible. If you've got traces in there or whatever it is, they will all be visible. So in this case, that should be all fine and dandy. So you just look for stuff like that, silk screen over pads and other stuff. You can do all this as DRCs, which we'll find out in a minute. But this is a one-off board. We simply don't care. Like, there's a dot here, for example, a silk screen dot for pin 1 marker of that SOT 223 package there. But we just don't care. Right, so you would fuss about this sort of stuff if it was a proper production board. You're doing it for a client or a company or something that's professional and everything else. You'd go to town, but we don't care. It's a one-off. So what we want to do now is we want to do a DRC, a design rule check. So we go into design rule check, and I'm pretty sure I've shown DRC in the previous video, did I? If not, my apologies. We run our DRC check, and once again, all of the electrical, you can enable and disable all sorts of various stuff in here, what you want actually checked. The online one, whether you do it live or via the batch thing, which is what we're running now. So anyway, let's just assume that we've got all of our settings set up correct, and bingo. This is the ultimate goal before you get a board manufactured, is to have 0 DRC errors. So all your traces are connected. All your connectivity matches all the pins. There's no breaks in any of the tracks. There's no shorts on any of the outputs. I've covered this in previous videos and stuff like that. And you've got there's no violations, like we're checking clearance constraint. Okay, so we've got 0.381 millimeters. What's that in? Here we go. If we switch back to Imperial, we're now in Imperial. Look at the bottom right corner there, and bottom left corner, sorry. And we run our DRC again, design rule check, bingo. It should give it to us in mils. There we go. So we got 15 thou clearance, 15 mil. Mil is the same as thou. 15 thou clearance. We've got no short circuit constraints. We've got no unrouted nets. We've got width constraints. So we're 10 mil, so we've got 10 mil clearance, 10 mil width, and we're checking hole-to-hole clearances, all sorts of stuff. We can check a lot more, but we don't care. It's a one-off board. It's looking good. It's looking good in 3D view mode. The vibe, it's all about the vibe. The vibe's happening. It's all there. So next step to get our board manufactured is gerbers. I think I spent quite a significant amount of time in the previous video talking about out jobs, and that's a different way to automate this sort of process. Automate doing DRCs, automate this board release process, as it's called. You do a DRC, you will do the Gerber file generation, your NC file generation, you might export a bill of materials, you might do all that sort of stuff. We're not going to go through that. That's like an Altium specific thing. I want to keep this as generic as possible. So what we want is fabrication outputs here, and we want our Gerber files. We won't do the new Gerber X2. We'll just do the traditional Gerber files. Inches or millimeters doesn't really matter. Everything's such fine resolution anyway. The manufacturers are just going to handle it. It's not a problem. And the format, 2:5 format, it explains down there. 2:3 has 1 mil resolution, so you don't want that. It's okay for a rough board like this, maybe, but 2:4 has 0.1 mil resolution, and so 2:5. You just want the highest resolution possible, just because the vibe. So we want to go in here and we want to plot our various layers. Okay, so let's Whoop, and these are going to be the file name extensions down here for the ones we want. So what do we want? We want our top overlay because we want the manufacturer to print us the silkscreen overlay. That's the white one there with all the component designators. We do not want a paste mask because we're not getting this manufactured professionally with a solder mask stencil, a solder paste stencil, so we don't need that. So we want the top solder mask because we're basically going to get a standard double-sided silk-screened solder masked board. So we want to do the solder, we want to do the top layer, we want to do the bottom layer, the bottom solder, no bottom paste, and we want the bottom overlay as well, because we manufactured this on a prototype PCB panel, which generally includes top and bottom overlays or top and bottom silkscreen. If you hear me use the word silkscreen, I refer to overlay and vice versa. It's the same thing. Silkscreen is just an old term for it. No one actually does real silk screens anymore, but you know, it's just a die-hard term. And then mechanical layer 1. In this case, let's actually, well, I'm sure I showed in the previous video, I did the board outline as mechanical layer 1 as some traces. So we will include that and we'll see it. So this is a real simple board. We don't have anything else fancy. And we do not want to add the mechanical layers to all of the plots. You want to separate it out. There'd only be specific reasons, manufacturer-specific reasons that you would do that. So they're all the layers we want. Top and bottom, silkscreen, solder mask, and trace. And drill drawings, we're not fussed about any drill drawings. Apertures, we would just embed the apertures in there. We'll just leave it all default. We're not mucking around here. Now, this is a reasonably important one because you have to define the size of the film. I'm just going to, this is a massive size film. What is it? 20,000 mil by 16,000 mil film. The film means the actual board size on the generated Gerber file. It's more than big enough for any size board that you might want, but the reference is important. So the position of your board on the film, we want the reference to be relative to this origin down here, which is this origin 0 marker that we set. So it basically sets it smack in the middle and then like in the middle of our film. You've got a center on film option, but reference to relative origin is just fine. So separate file per layer. Everything optimized, changed, just all default stuff. We don't want to muck around with anything here. Suppress leading zeros, don't worry about that. It's all default, and we go, okay. That's it. It's generate. You saw it down the bottom. Bingo. All of our Gerber files have been generated, and it generates a Camtastic file, .cam over here. This is an Altium thing. I think Altium bought Camtastic or something donkeys years ago. And this is now not our PCB file anymore. This is actually a composite view of all of our Gerber layers superimposed one on top of the other, and we can view individual files down here. So we can go Camtastic documents, and here's our individual layers, because Altium has a built-in Gerber viewer, basically, and Gerber, it works okay, good enough for just viewing. It's not the best thing in the world. There are better third-party Gerber viewer programs, but anyway, this allows us to simply go in there and look at the individual layers. So now we can see that's our bottom, and you see how it actually has no border and where the origin is here, okay? So that origin is important, that origin. Otherwise, if we said center on film, the origin would be way down in the other corner or whatever, okay? Oh, that was a bit of a display bug there. Oh, look at that. Ha! Display bug. Oops. I don't know if my screen capture is interfering with that or not, but I can certainly see that. And you notice how we didn't have that option to add the board outline. We simply don't need it, okay? So that's GBL, so that's BL is bottom layer, so GBL stands for Gerber bottom layer. That's sort of like an industry standard file, naming convention, extension convention. There's our bottom silkscreen, our bottom overlay. BO stands for bottom overlay, and BS does not stand for what you think it might. It stands for Gerber bottom solder mask. So that's our solder mask expansion on the bottom. And this is our mechanical layer, as I said, because I manually put those traces. Oh, Have I left a gap up there? Did you see that? I left a gap up there. It doesn't matter. They're going to know what it is. They're going to know that that's my board outline and I've just goofed it. It's going to make no difference to them. So I wouldn't even bother fixing that. Maybe if it was a professional, thing and a real complex board, I might fix that. But it's obviously this is just a plain square board. That's really all they need to know. And there's our top layer traces. So it all looks nice and clean. It all looks like it's generated nicely. Our top overlay. Yep, there it all is. And our top solder mask. So it all looks hunky-dory. Happy as Larry. So we're almost done. We've generated our Gerber files, but the Gerber files are just the film files that generate the masks that manufacture the board. But that doesn't have any information to do with actually drilling the board. So we have to generate NC drill files, they're called. So if we go to fabrication outputs again, we go NC drill files, and once again you can automate all this, so it's a single, almost practically a single click to do all sorts of stuff, generating Gerbers, NC drill files, bill of materials and DRCs and all sorts of stuff if you want. But yeah, once again, we're going to do the inches thing, 2.5 here, suppress trailing zeros, reference relative to origin. You want to make sure that matches your one before. Otherwise, you're going to be, they will not line up. When it imports into their CAM software, both the NC drill file and the Gerbers, they've got special CAM software. They do not use Altium, by the way. If you think the manufacturers will import your Gerber files into Altium and then print them, that's not how it works. They've got special CAM software that handles all this. So if the origin's not the same, nothing will line up. I mean, they probably wouldn't be silly enough to just go and press manufacture, right, and do it. But they'd have to manually fix it, and they'll probably charge you for that, or they'd come back and tell you, or something like that. They should come back and tell you, hey, you don't know what you're doing, in a nice about way, and your origins don't match up. But the problem with PCB manufacturers is they often will not tell you anything. They will just fix stuff. So you could be sending them boards for years in the wrong format, and they will just fix things. A lot of them are not good at telling you that, hey, this isn't the best way to do it. Here's what you should do, which is good in that you'll most often get working boards back. But yeah, they don't like to help you out in any way in that respect, which is not a great thing, because that doesn't help them out. It's extra work for them to do, but I guess they just secretly charge you for it. Anyway, reference relative to origin, same as before. Optimize, we don't want any of this. Generate separate for drill files for plated and non-plated holes. We're not fussy about that. This time, use drilled slot commands. We're not fussy about that. We've got no slots or anything. We're just going to go bog standard. Thank you very much. Import drill data. Just leave all this standard. We won't change any of this sort of stuff. And bingo, there is our, once again, it's generated a Camtastic file. Once again, the origin is over here. So if you merge those two Camtastic documents, that all overlay and everything else. So here is the actual file. So we've generated our Gerbers and we've generated our NC drill files. We're ready to go to the manufacturer. Woohoo! All right, so we have generated our files. They're going to be in this subdirectory here, project outputs, and here are all the wonderful files that we've got, all our Gerber files. Now, it's generated a few additional files which we don't necessarily need to send to the manufacturer. Like, I don't think we had any slots in here, right? So were there any slots? It says there's the odd slot. Oh, yes, we do have slots, sorry. The DC jack over here, the 12-volt DC jack, is done with a slot. They're the NC drill file commands for actually drilling those slots. Use this drill size, put it in there, move it X millimeters in this direction, etc. And then we've got the round holes. These are most of our holes in here. So once again, it comes, if you want to know the format here, it's got like T1 stands for tool 1. So this is the tool. These are plated files. I shouldn't be going through the format. And this is the, and in inches, we probably should have done this, actually, we should have done our NC drill file in millimeters, shouldn't we have, David? Yes, David's nodding in the background. Let's do it again in millimeters. And the reason we're going to redo it, like, we don't have to. This is just purely for our entertainment purposes, really. So let's... Oh, I wasn't... David's laughing in the background there. Export. NC drill. He's a big fanboy of everything metric. NC drill files again. Let's try that again in millimeters, just so it's easier for us to read. And technically, they do use millimeter drill bits these days. Every 0.05 millimeter increments, or they'll have a whole stack of on the machine in like 0.05 millimeters or whatever it is, and they will increment those. So they would have just, like, their software would have automatically handled that and converted the imperial to the nearest metric drill. It would have been, would have been fine. But just for kicks, we will redo that, and we'll go back to our file over here and round holes. We are now metric. Thank you very much. Plated holes, 0.6 millimeters, that'd be the vias, 0.85, 0.9. And once again, you get charged for these what are called tool changes. So you actually want to minimize these. So if you're doing a real complex board and you're importing libraries from everywhere, and they might have subtly different drill sizes, one might be 0.8 instead of 0.85. And you might, like, if you've got a real hodgepodge design, getting parts from and libraries from everywhere, you might end up with like 20 different drill hole sizes. So you want to consolidate those. That would often be a step which I didn't cover here. You would for a professional board that you're getting, especially high volume manufactured. When it's a big deal. This prototype doesn't matter a rat's bum. But, you don't want to have 20 tool sizes, because that'll slow down your board. They won't be able to produce as many. They won't be able to produce them as fast enough. They'll charge you for that extra machine time when it's got to go in and change the tool from the 0.85 to the 0.80. So often hole size consolidation is another entire step in the process, which we didn't do here, but just be aware of that. And then you've got non-plated holes, 4 millimeters. That'd be the big mounting holes in the corners here. And then they go tool 1. There it is. And here's all the commands, the NC drill file commands, move in X direction, blah, 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 etc. And that's all the file is. But you don't need to know that. I just showed you that because... Okay, some other files in here which you don't have to send to the manufacturer. For example, this DRR, that's a drill report file. So if we open that, it can give you some valuable information. Here's the tools. That's stuff I said before, number of hole counts and all that sort of jazz, and total tool travel. That determines how long it's going to take them to actually drill this board, because it takes time for the NC drill machine to move from one spot to the next. So the tool travel time in distances can matter and stuff like that. So we don't have to include those files. It doesn't matter at all. So in the zip, generally you just want to zip them all up. So what we want to do, the aperture file, I don't think you have to include that these days, but I just do as a matter of course. And I also include the DRR, just because they might want to see it. It might be nice for them. We don't need external rep file, but we need all our gerbers. But just include everything. Why not, right? Simulation net list, we don't need that. So we might actually leave that out. So we'll highlight all those, and we need of course, our text files. Once again, I'm pretty sure they don't need the aperture library and stuff like that, but just send it. Just send them everything. It doesn't really matter, right? So they'll just ignore the ones. So we will zip that up. Project outputs. Zip. Thank you very much. There it is. And we're ready to send our zip file off to the manufacturer. Beauty. Now, just before we actually go to some PCB manufacturers and get quotes and things, online quotes, just a quick word about board size here. Now, people these days just expect, prototype boards, dirt cheap PCBs or Oshpark or something like that, $5-10 a board or something like that. No, right? It's not going to be $5 or $10. Why? Because look at the board information. It's about the size. Sorry, go to millimeters. Board sizes, yeah, okay. Board information. It is 185 millimeters by 69 millimeters. Now, that's not a huge board by any stretch of the imagination, but it's much bigger than the average person's doing a little Arduino shield these days, and they're so used to buying these cheap boards, right? But 185 by 69, that's about 20 square inches. Right? In the old money, right? So, and let's go To OshPark, for example, you pay $5 per square inch for its standard 2-layer board. Yeah, you get 3 copies of your board. I don't need 3 copies, right? But, hey, that's $100, right? It's not a $5, $10 board because you pay, when you're taking up a large part of a prototype panel surface area, they're going to charge you for it like a wounded bull. So, yeah. Don't go wildly down in the comments, oh, you can get it for $10 at here. No, you can't. Okay? The board is bigger than your average shield. Now, I may not actually use OshPark to get it manufactured. In fact, one of the PCB manufacturer we'll see later actually gave me a half-price coupon, so I might just use their service just because they gave me a coupon. I'm a tight ass, right? But hey, let's try OshPark because I've never actually gone through and done a full thing with them. I may not get it ordered, but let's just, select the files on the computer. Can we drag and drop? Oh, we've got to select. Can't drag and drop. I want to drag and drop. Bugger. No. Brr. Now, here's one thing. Like OshPark and pretty much, you saw it there before, they actually accept Eagle board files and KiCad files directly as well. I don't recommend you do that. Any decent PCB manufacturer will accept Altium files directly. So the Altium PCB file or whatever it is, right? You could just send them that PCB file and they will get your board made. They may not question it at all, but it's not the most controlled way to do it. So the reason that you generate gerbers and do everything else is that you can check everything and, you manually know what you see is what you're going to get with gerbers and the NC drill files and everything else. So I highly recommend learning how to generate gerbers and doing it that way, and not just lazily upload your Eagle board file. If you're doing a one-off, okay, it might work just fine, but if you want to do anything semi-professionally and you want to control the process, Gerber files is the way to do it. That's how all your professionals do it. So 2-layer board of 7.29 inches by 2.7 inches. It looks like it all works in as an Altium zip file. There you go. It's automatically recognized it. Detected unsupported drilled slots. There you go. Doesn't OshPark support slots? Your project contained 2 drill files. We've merged them. Maybe that was the issue. Now, something's gone horribly wrong here. It does not like this. Look at this. Our drill file, our board bottom, it has not expanded that to scale. So I don't know. It is not working. Top layers worked just fine and dandy. The GTL file, the Gerber top layer, bottom layer looks spectacular. That's all lined up. Everything's hunky-dory. Solder masks are all good. The board outline, there it is, GM1. It knows it's a board outline. It's a pretty industry standard method of doing it, so I guess they know that you use one of the mechanical layers as just a board outline. It's detected that. So that's really quite groovy, but I'm a bit concerned about the drill. That's not going to work. So we might have to fix that. That's not what this video is going to be about because I don't intend to use OshPark anyway. They're not hugely quick. They're not hugely cheap for a big board like this. Let's go look at some others. But yeah, normally that should have worked. So maybe there's a bug somewhere or I didn't use something that wasn't compatible. They actually tell you. There you go. Absolute coordinates. They wanted absolute. They wanted absolute and not the origin. Let me see if I can fix this, just out of curiosity. Okay, I'd love to show you OshPark working, but I re-uploaded by removing the trailing zeros and 4.3 and the whatnot using the absolute origin, but it just hasn't worked, so I'm not happy with that. I'm just going to, assume that there's some quirky little thing happening and we'll move on. Okay, I think I officially give up. I went to the effort to regenerate all the Gerbers in absolute origin using Imperial 4.3, to match the NC drill files, and it does not work. So that maybe it's the merge of the 2 files. It didn't like that or something, and it's like, nothing works, even following their sort of instructions there. Now, because all PCB manufacturers are always chopping and changing who's the best, who's the cheapest, who's the fastest, who's the best quality, blah, blah, blah. You know, like, you can't keep up these days. More PCB prototype manufacturers than you poke a crow probe at. It's unbelievable. Anyway, so I'm going to use like a PCBShopper service. I've never used it in Anger before. It searches a lot of different, actually, in these ones, 25 different PCB manufacturers. PCBWay, Seed Studio, Shenzhen thing, Osh Park as well, Breadboard Killer, which is an Australian one, Dirty PCBs, dirty, cheap. Reminds me of Akadaka. Dirty deeds, done dirt cheap. Dirty PCBs, done dirt cheap. Anyway, Thunderstruck. Yeah, so let's go in. 185 by, 69, sorry. 69 millimeters, 2 layers, least expensive color. We're just not fussy. It's just a prototype thing. We don't care. We can do both, but, you know, really we only need top. You know, I'm a tight ass, right? So we don't need that bottom silk screen. It's rubbish. In fact, we don't even need the top silk screen, really, but you know, you're probably going to get it for free, whatever, because it's on a prototype panel. Surface finish cheapest, you know, we don't need like gold or anything like that. No, none of that rubbish. Standard 1.6 millimeter thickness, standard 1 ounce copper, none of that thicker rubbish. 10 mil trace and space. We've got a very coarse board here, no fine tolerances, so anyone can make this. You can make this at home with your own laser printed transparent overlays. I can do like 8.8 at home, easy, even down to 6.6 sometimes at home. I've done way in my deep, dark past, double-sided even. Anyway, 10 mil. So, because that will have an impact on your price. What services are available to do your minimum trace and space. So, 10 is plenty. Minimum drill size, 0.6 millimeters. You can select either. I think our one was 0.6 millimeter, smallest via, no gold fingers, no stencil. Because we're not stencils, the SMD stencil. A lot of them will include like a free Mylar, a cheap ass Mylar stencil or something like that. Maybe, a few of your higher priced ones might give you a free stainless steel stencil or something like that, which is nice if you want it. Certainly if you're doing a board, and you're going to reflow oven it, you throw in a stencil, please. Quality certifications, don't want any of that rubbish. Number of designs, 1, quantity 1, Australia. And default time, you can set the number of business. Let's go default. Let's get prices. This is what we want to see. Here we go. This is quite jazzy. Look at this. Right, so Seed Studio, look, it's going to cost for 5 boards. Okay, there you go, $712. That's pretty good. That's pretty cheap from Seed, isn't it? Wow, have I got the right dimensions? Even 9 days. Oh, sorry, Easy EDA's beat them, has it? Is it sorted by cheapness? Wow, look at this. I like this service. This is really quite... And it linked to jump to the order page as well. Great. 43 days registered airmail, DHL Express. So that's total boards plus shipping. That's pretty good, actually. $56. That's pretty cheap. From Easy EDA in China. Wow, green. Standard green solder mask or whatever. But that's pretty jazzy. Seed Studios also, punching above their weight there at $68, all PCB, PCBWay. A lot of people are talking about PCBWay at the moment. They've got a good process that follows. I think it's PCBWay who follows step by step through the production process, which is quite good. I can't remember which one I've got the half price coupon from. Might be them. Anyway, DHL, including DHL postage. So the board itself is okay. Well, you can get it for $17 total, actually. But then the shipping, of course. Shipping costs more than the boards do. So that's actually, I'm very surprised at that for a board of this size. That is quite surprising. So you can see this is a really good tool to, look, dirty PCBs. A lot of people say they're the cheapest. Well, not for a board of, 185 millimeters width, for example. It's not very high. It's only like 69 millimeters high. Which isn't much, but that width adds. PCB Cart, I've been using PCB Cart for like a decade or something. They were one of the cheapest pioneering companies in terms of shared panel service. When PCB Cart originally came out, that was pretty groundbreaking. And Breadboard Killer here in Australia, they don't make them here in Australia, they just subcontract out. So, even that's like 12 days delivery. So once again, you've got a PCB zone in New Zealand. Hi, Richard. So there, then we start getting into the $100 region, but the quality of their boards is really good. And 5 days, right? So that's, that's pretty quick. So, you compare that to, well, we can have it 9 days up here, total days for those. So, these cheap ones, yeah, 8, 9 days, and that'd be working days too, probably. I know that PCB cart they're usually specified working days. So anyway, PCB with a 5-day lead time. And of course, if you want, that's why I was probably I was basing. Let's say we want it in 4 days, right? Let's go do that again. Let's go do. We're in a hurry. We want our board, damn it. And now you'll see it be much more pricey. So if you're happy to wait. There you go. PCB Zone in New Zealand is going to be the cheapest so far at 155, including DHL. So you're going to get that puppy in 3 days. And $131, that's not much to, like when I was a boy, right? That was unheard of to get a prototype board for $130. It was like, $700, $800, $500 for a new, whiz bang cheap service because you paid for the whole panel. But now everyone's doing these shared panel services, and that's, awesome price for 3 days lead time. So there you go. New Zealand, who knew, right? PCB, everyone thinks, China's the cheapest. Not according to PCBShopper here. For your 4 business days, maybe if we get 5, because 5 is a more sort of standard fast process time. I think we'll have a few more choices here. This works great. It's just sucking the data from all these PCBs. No, it's got a few more, but once again, PCB Zone is winning. So actually, there must be a quirk in this because the other companies offer it. So why it's not, they do offer such a service. So why they're not showing up, I don't know. Because if you go into PCB Card or PCBWay or anyone like that, if you go into their website directly, they will give you an option. For, really fast turnaround boards. So, yeah, I don't think this is complete. I would not take this as gospel. So, yeah, here's an example of that. If I go over to PCBWay, for example, they're closing now for 2 days holidays. Too bad if you want to get your boards made, as in right now. They won't start for another day or so. Beware Chinese New Year. 2 to 3 days. Look at this. So I've put in all my, 185 by 69, only with different designs on panel 1. And they're going to give me 5 boards as the minimum you can get made. And they're going to do that for $32 with 2 to 3 days turn. But of course, once you choose DHL to Australia, that's still pretty good. $57 for 3 to 5 days. That's really good. We didn't get that option over in PCBWay. Here it is, $114 with 6 days. So there's something going on there. Something's not right. The website is, PCBShopper has failed us, I'm afraid. And check this out. Express 24 hours, $55 for 5 boards. You've got to be kidding me. David thinks they're lying. Why do you think they're lying, David?
Crazy fast.
It's crazy fast, isn't it, for that price?
Yeah.
That's just insane. How big must their facility be to have a spare line for you to bump everything out?
How quick are they replying with emails?
That's nuts. 24 hours turn. I don't have the boards quicker than I have my DigiKey parts almost. Wow. Tempted to try. Okay, I'm on the Elecro website. They actually offered me a 50% discount coupon. They have a ridiculous array of options here. I just wanted to show you this. This is 5 pieces, 2-layer PCB. It seems expensive in quote marks, but this is a rush 12-hour job. Rush 12, shipped in 2 working days. So whether or not they actually manufacture it in 12 hours, but it takes them 2 days to ship it. Or does that include shipping? I'm not sure, but it's just crazy. And if you go back here, look, they have a 4-layer piece. You can get 100 pieces of a 4-layer board. I haven't costed this out on other sites, so it may actually be the similar price or cheaper, but 5 centimeters by 5 centimeters, okay. But what if you wanted 5 centimeters by 30 centimeters? It's still only $369 for a 4-layer board with all the bells and whistles, right? Well, no, it doesn't. Okay, gold is $16. Okay, wow, whoop-de-doo. For 100 pieces of a 4-layer board, like, what world are we living in? This is insanely cheap. Right, so I'm looking at the 5 pieces, 2-layer PCB here. I've got to choose the 10 centimeter by 20 centimeter max because I'm 185 by 69. So it's not, it's not ideally optimized. You've got jumps up there, but red's solder mask goes faster. Everyone knows that. So we'll choose the red. We don't want $12 for our gold. But check this out, stencil. With a frame, I'm going to, this must be a stainless steel stencil, right? And because you only get stainless steel stencils in frames. Well, they only ones that come with frame option. So a 30 centimeter by 40 centimeter, that's pretty decent size for $18. $18, a lousy it's practically free. When I was a boy, like a $500 stainless steel stencil was cheap as, right? This is like, we're living in a world where things are practically free and people take it for granted. Unbelievable. So anyway, I can rush 12 hour. Oh, man. It's just... wouldn't want to go back to the old days, that's for sure. When I was a boy. Okay, I won't bore you with the process of ordering that board through Elecro, but I did. It'll come in, well, it'll be manufactured in like 2 to 3 days or something. They very kindly gave me a discount code, so it was a bit cheaper than PCBWay. And anyway, not sure what happened to the Osh Park one there, but no shortage of services these days to manufacture your boards. It's just crazy. I was just talking to David about it. He has grown up in a world where he has not had a low-cost PCB manufacturing service. So, yep, crazy. Anyway, when I was a boy, we didn't have these low-cost PCBs. So there you go. That's just a quick walkthrough. This wasn't designed to be a tutorial. Otherwise, it would have been a bit more concise than this. It's just me waffling on, getting this board made. So the next part of the video, we'll get the board in. I'll order the parts from DigiKey or wherever. And because the driver chip has to come specifically from DigiKey or Mouser or someone like that, you can't get it here in Australia. So we'll get the parts in, we'll assemble it, and we'll get it working, and I'll show you the final product. Anyway, hope you enjoyed it. If you did, please give it a big thumbs up. As always, discussed it in the link down below. Catch you next time.